and see how we do. Cool. So hello and welcome to my session about ScyllaDB and Kubernetes. My name is Tomáš Nožička. I'm a principal software engineer leading the Scylla Operator team here at ScyllaDB. For those who joined earlier, you heard the story about me and Kube, but I used to work on Kube before I joined Scylla, so I was part of the Kubernetes SIGOps, a maintainer and approver there, and also working on OpenShift when my time with Red Hat as well. So Scylla Operator. Scylla Operator is a Kubernetes operator for managing and automating tasks related to managing Scylla clusters, and it is the tool we use for running Scylla on top of Kubernetes. As that setup is a bit complex to do manually, there is the operator to automate things for you, right? It is essentially a set of Kubernetes API extensions where you define how you want the cluster to look like and controllers that reconcile the desired state. It is an open source project, so feel free to check out our GitHub. File issues there, contributions are welcome as well. We do have a dedicated docs pages too, so if you don't like to read the MD files, there's a nice website very similar to all the Scylla docs you would see for the other components. Before we jump into the Scylla Operator, I wanted to do a brief comparison and explain a bit of the differences between how you would run a Scylla on the old VM deployment and on Kubernetes, right? So going into the VM-based deployment, you do a one Scylla instance per VM. It runs directly on the host. There's no isolation like the process namespaces, network namespaces, and all the other stuff. That's just runs on the host as it always did. The VM is dedicated for one tenant, and the Scylla has direct access to kernel devices, or the other processes running on the host. If you need to execute a maintenance, an upgrade, it is done manually by the administrators, right? So an administrator would check the Scylla documentation, what is the procedure for an upgrade, and execute all those steps manually or with an Ansible or something. But he would have to wait for it to complete. If not, he would have to retrigger it and hope it finishes again, but it would still take all of his time. And it is kind of error prone if you have a lot of nodes. It's just better to automate it, right? And that's what the Kubernetes is doing. The difference there is it gives you a declarative API. So you just say, I want the cluster to look like this. I want to have 3 nodes, and you don't care about the actions that needs to be taken. That's the job for the operator, right? So if you want to trigger an upgrade, it will automatically do a rolling restart. It will automatically check that all the nodes are up before proceeding to the next node. If that's an upgrade, it will snapshot your key spaces and delete those snapshots if the upgrade was successful. It also reports the status for you, right? So with the declarative API, you get the 200 response right away. It just been stored into a database. Then the operator asynchronously tries to reconcile the state that you defined, and it reports status back. So you get the observability as well, but you are not the one responsible for the actions that need to be taken. As it is Kubernetes, everything runs in containers there. So it is a multi-tenant environment where you can run multiple Scyllas on a Kubernetes node. Because it's multi-tenant, there's generally a shared pool of resources. You can, of course, ask for a dedicated CPUs, but you can share them as well if you decide to. And because it's a multi-tenant environment, say the devices are virtualized, right? So there are abstractions like persistent volume claims and persistent volumes. So the actual pods needing that storage don't have to have elevated permissions to mount a device on a node, and it is done by kubelet on its behalf. So here's a brief overview of the architecture when you deploy the Scylla operator with all of its components. You can see the Scylla clusters on right. If we focus on a particular Scylla node, there is also a Scylla agent running nearby it in a sidecar container in the same pod, which is used by the Scylla manager and provides him with an API for the management. The Scylla manager has a corresponding Scylla manager controller that watches the Scylla cluster resources. Say if you define a backup, it's going to read that definition from the Scylla cluster API, and it's going to sync them into a manager and configure it to do a backup in the schedule that you asked for. For the manager, you can also use the SC tool, but there is just one manager, so this is mostly for admins to check stuff, but it's not really multi-tenant. The Scylla manager itself has a backend data store, which is essentially a one-node Scylla cluster that it uses to store progress and generally as a maintenance data store. The third big component here is the Scylla monitoring stack, which consists of Grafana and Prometheus. Since 1.9, which is the next release, this is actually going to be fully managed by an API. So there's going to be an alpha v1 resource defining the ScyllaDB monitoring, and it's going to set up all of this for you. So with that, let's actually look into how it works, right? So here's an example of a Scylla cluster API resource. Most of the Kubernetes resources are divided into a spec and a status. Spec is the part where you define the desired state, right? I want a Scylla with version 5.05. I want an agent version, which is the sidecar there, with version 3.01, corresponds to the manager version. And I want one data center with one rack, 3 members, each 200 gigabytes of storage, 8 CPUs, some memory as well. And that's it. Essentially, obviously, you can define more options there if you need to, but this is pretty much the basics, right? This is all you need to create a Scylla cluster, which to me is fairly easy. There's also the status part, which is filled in by the operator continuously, and it describes the state the operator sees, right? It is obviously shortened in the slide. There's much more info in the status, but I needed to fit in, right? So there are conditions telling you, is the Scylla cluster available? Is it progressing to a new state? Is it degraded because something broke? And there are corresponding messages describing why it is degraded or why is it progressing. So you can read a lot just by looking at the state, and you can understand what the operator is doing. So what the operator or controller, and it's pretty much ambiguous, is doing, it's essentially a loop that observes the API resource you defined. It checks what the cluster state is, right? So it looks to kube, like you said, there should be 3 members. Do I have 3 pods corresponding to those? If you have 2, it's going to calculate, I need to create 1, right? And it's going to take the action and create it to reach that state. So essentially, this is a loop. If something fails, it's going to try again and again with a backoff, and it will eventually reach the state that you defined. You don't have to retrigger anything. You just define the end state, and the controller will take any action necessary to get there, and it's going to keep trying. So there are obviously other APIs as well provided by the operator to run Scylla on Kubernetes. The next one is Scylla Operator config that configures the operator itself. Then there is a node config, which you would use to enable node tuning for performance reasons, and also set a node options. It's also where we are going to do more stuff in the future, so stay tuned there. And there is a ScyllaDB monitoring, which is going to come in the next version, 1.9, which will set up a full monitoring stack for you and connect it to your Scylla cluster. As those APIs evolve, we do our best.
Thomas, we had a question here. Speaking of storage, do you recommend using any specific type of storage and also type of storage driver for running Scylla in Kubernetes?
Oh, sure. So our recommendation is to run on local NVMEs. That is currently so there are more than one option, right? Like if you don't care that much about performance or you want to set up a dev cluster, you can just use any storage you want, right? We generally recommend.
There's any recommendation? Oh, okay, go on.
we recommend using local NVMEs for production, as that is how you get the best performance, and that's what we run in production, and this would be test with. That is generally done by these days with 6 storage static local volume provisioner, which you set up with a path on a host, and it's going to do provisioning from the devices or from a directory structure for you. And that's what's going to create those PVs. There is no particle driver for this, right? It's mostly the abstraction that needs to be done.
Thanks for the answer.
Sure, no worries. So APIs. We talked about some, but the set is generally growing, and we add new fields in a backwards compatible manner, so they are optional throughout the time. So we obviously advertise this in our release notes, but there's also a way how to use the Kubernetes Discovery API to learn about what resources are being supported in this Kubernetes cluster. So you could do kubectl API resources. You could either use our group or not. This is really not related to Scylla. It works for any other API resource. And you can list the available resources that are installed in the API server. The other one, and that is, in my opinion, the most important command you should learn from kubectl, is kubectl explain. This is able to reach to the API server, read the open API spec there for a particular resource, and it's going to give you the documentation for it live, right? If a custom resource definition is installed into an API server, this is going to give you exactly the corresponding output for it. So say we want to find out what are the fields in the node config spec, right? What can I configure? So we just do kubectl explain node config spec, and it will list you all the fields with all the types and all the descriptions for those fields. You can also do like node config.spec something else, so you can iteratively get into what you need to fill there if that's a nested structure. So remember that one. That is super useful. With the APIs done, I wanted to mention some features that are supported in the operator compared to stuff that you had to handle somehow. We already talked a bit about the orchestrated updates and upgrades, like doing the rolling restart, checking all the preconditions, doing the snapshots, key space snapshots on upgrades, and deleting those if it goes successfully, right? There's also the scale up and scale down, which you're going to see later in the demo as well, where for the operator you just say, I want 5 instead of 3, or you want 3 instead of 5, and the operator will say if you are scaling down, it will know it has to decommission the 5th and 4th node first before actually deleting the resources for it. So it's going to run the decommission procedure for you, and then it's going to delete those resources. You can also change the resources and other properties, right? So say you choose to do 2 CPUs for a Scylla node, right? If you want to bump that to 4, just change the desired state, right? Just say you want 4 instead of 2, save it, and the operator will get there. It's going to run a rolling restart, and it's going to update resources for you. Obviously, like, you need to have a space on the node.
Thomas,
sure, Daniel.
We have a question here. When using SQL, how do we connect externally to use the ScyllaDB operator? Can you elaborate that?
I can. It's a longer story.
Oh,
but yeah, since you already started with it, that is a bit complex. The operator today and historically is set up to use a service IPs, which are virtual IPs in the Kubernetes cluster. So inside the Kubernetes cluster, you can use those service IPs. I know the question was obviously for the outside, and that is a bit hard. As those are only virtual IPs, they are essentially just IP table rules on the nodes. I didn't find a way to propagate those properly through the routing tables out of the Scylla cluster. We are thinking and trying to switch to pod IPs as well, which can be propagated outside of the cluster. And that's one of our work for a multi-DC, because obviously you need different Kubernetes clusters to talk to each other. So that is one way. The other, there is an experimental feature for the operator that we haven't really, for a bit of a reason, documented because it's very alpha. But there is a way to expose the Scylla clusters through ingresses. So I don't think we are going to go into the details here, but if you reach out to me on a Kubernetes Slack, I could point you to, like, RCI is actually set up to do this, I think. So it sets up all the ingresses and TLS certs for it. It's a bit complex, but if you reach out to me on the Slack, I would be happy to figure out something
Thomas,
for you.
Thank you for your answer.
You're welcome. Thanks. So I was talking about changing resources, just changing the desired count, say for CPUs from 2 to 4 and 2 to 4, and the operator will just do anything necessary, do the rolling restart, set the new arguments for Scylla, and just make it happen for you. And that goes for the other properties as well. It also supports automatic node replace. So say if in your Kubernetes cluster a Kubernetes node dies, and the admin will remove it from the cluster. With the local storage, a persistent volume is going to get stuck there because it's bound to a node that doesn't exist anymore. So if you enable that feature in the Scylla cluster, the Scylla operator will recognize that state, delete the PV object, and essentially allow your new node to be created in its stead on some other Kubernetes node, and stream all the data there. Well, not all the data, but all the data that the node had. We talked a bit about the managed monitoring setup, which is the alpha feature in the upcoming release. So that's just like, you will see it in the demo how easy it is to set up. Also, since the operator 1.8, I think, there is an alpha feature that can give you automatic TLS certificates for CQL. You just need to enable it, and it's gonna like rotate them and do everything that you would otherwise need to do manually. So you get like the serving certs, client certs, the CA bundle for it. Everything is gonna be set up the right way. That's for the client to node. TLS node to node is gonna come in the future. And there are many more. Just wanted to pick up a few that show how the automation makes it so much easier to run on Kube than when you have to care about your pets, aka VMs. Wanted to lay out also some of the future work we do. So as you mentioned the question about a storage setup, right? There are many ways to do it, right? That's why we haven't really gone too much into it. It is described in our docs as well. It is a bit of a complex process. It's not terrible, but it is error prone, and a lot of users hit some mistake, misconfigure the paths for, say, the local storage provision, or for the other thing that makes the PVs, or you have to use a full device, which is harder to share, right? So we want to make that setup more managed, and there's a lot of work that is going into it. It's going to land in one of the future, well, not probably, but one of the future ones that's going to have it, and it's going to make the setup so much easier for users, even with local NVMEs. If you just use the cloud storage, it's easy even now. We also want to work on the managed storage expansion. Currently, when you need to expand the storage, there's a bit of manual steps involved. So we generally want to aim to have all of it managed by the operator and a more seamless experience for the users. We also want to do the same thing with backup and restore. Still a bit of manual steps today. There's a bit of performance enhancement on our list as well, although we are very close even today. We want to do release channels so you can manage a fleet of Scylla clusters easier than added the Scylla version for a bump in every one of those. And as we kind of bump into it, we want to do multi-DC as well, which is a big one for our backlog, but there has been effort like enhancing Scylla so it can live with transient IPs. So we can actually switch from service IPs, which are not routable outside of the cluster, to pod IPs, which would be routable. And there's a lot of effort going around that, but that's a big one. And there's other stuff as well. Don't want to bore you here too much. A brief mention about our releases. We aim for about a 6-week cadence, super the latest too. So you still have time to upgrade when we make a new release. And there's N-1 compatibility, so be sure you update through every major. Through every minor release. Like if you go from 1.6 to 1.8, you have to go through 1.7 not to skip any migration step. And with that, I would like to show you how you can actually easily set up all of this and run Scylla clusters in almost no time. Let me just switch to my terminal. Actually, I guess at this point I can just share the whole thing. Cool. I've actually made a capture like a few hours ago, because all of the steps we are going to run through today, they do take a significant amount of time for rolling out the Scylla clusters of a bigger size, right? So it's not speed up, but the empty spaces, they are limited to 5 seconds, right? So don't be surprised if you see something happening in a faster way than when you actually run it. So let me walk you through that. So we'll start by cloning the Scylla Operator repository, so we have access to the manifest that we need to deploy it. And before we actually go to the deployment of the Scylla Operator, we will first just install the dependencies that we need, namely a cert manager that is used for our webhooks, and a Prometheus operator that we use for part of the ScyllaDB monitoring setup. Right, so essentially all of these are just kubectl apply. We do provide some manifest for you, right? So if you go to the examples, you can find these. If you install cert manager or Prometheus operator in any other way, just feel free to skip this step. The important thing is we have the APIs available. However you get them, it is your choice. This is just an example of how you can get them, right? So Again, we provide a set of manifests in the operator repository in the examples, and you will just apply them. Well, if you ever try to script this, be careful and don't forget about the steps. Many people, fortunately, not many people know they should do this. If you register a custom resource definition with the API server, you have to wait for it to propagate to the other kube API servers, namely for the HA deployment, the API servers. So you need to wait for it to be established. So that's why we wait for it here and in every other custom resource definition. So the setup is not that complex, but if you want it to be flake-free, you should be waiting for these. So we do it for the set manager, for the Prometheus operator, and we wait for the deployments as well. So with the prerequisites done, we can actually deploy the Scylla operator. Again, we do provide all the manifests for you. So if you go to the deploy/operator folder and you just kubectl apply it, you get all you need. Right, there's like a pod disruption budget, the deployments, the CRDs, everything is there. So we will just wait for the CRD to be propagated to all the API servers. For the sake of correctness, if you just run it manually and you want to wait a few seconds, you can do that as well and retry in the worst case. And we wait for the rollout status to make sure the Scylla operator deployment has started and is ready. Optionally, depending on the license and how big your cluster is, you can deploy Scylla Manager as well. We do provide the manifests again in the deploy folder. There are actually two versions. One is dev, one is prod. The only difference is the accompanied Scylla cluster is giving a dedicated resources in the other one. As I'm running this on my local laptop, I just pick the dev one, which has less resources required. It's not really used that much. And we will wait for the Scylla manager to roll out. Obviously, this is the part where the Askinema cut out the waiting space. This usually takes like about a minute because it needs to wait for that Scylla cluster that backs the Scylla manager to roll out. So just noting it here. And optionally, if you want, you can enable the cluster tuning to give you a better performance. You do that by creating a node config object, which is one of the APIs we talked about. Again, if you go into the examples, there is a one that is provided for you as a start to bootstrap you, right? You essentially just need to go there and make sure your labels match, right? So this is our default node selector. You can either label your Kubernetes nodes for Scylla with this label, or you can adjust the label to the here to whatever you are using currently. Your choice really, but make sure this one matches so the nodes are actually tuned. And we will wait for the tuning to be set up. And now it is time to actually create, right? So everything run so far would be the administrator doing it at one time, right? That's the initial install. You could probably leave out half of the commands if you are running it manually. You just do the kubectl apply and wait a bit, and it would be shorter. For the sake of correctness, I did all the necessary steps, but it is not that complex if you just apply the resources and be done. That's fine as well. So we will create a demo namespace, and this is where the user level part starts, right? As a user, you want a Scylla cluster, and you have a Scylla operator already installed in your cluster, right? So before we actually create that Scylla cluster, we will create a Scylla config for it. It is not mandatory. I just wanted to give you an example of how you can change the Scylla YAML, right? On the VMs, that would be like /etc/Scylla.d/Scylla YAML, right? So this is how you can actually get it into the Scylla. And there is a config map, Scylla config, and you create this one, and the Scylla cluster will pick it up. So it's just a config map that you will kubectl apply in your demo namespace or whatever you have, right? And it's going to be later picked up by the Scylla cluster that you create. So this is the Scylla cluster API resource. We have already seen it in the slides, right? So it's pretty similar, except I didn't have 128 gigabytes on my laptop, so I downscaled it a bit. But for the other purposes, that is essentially the same one. And this is all you need to actually create the Scylla cluster. Just ask for the versions, and you say how many regs and what size. And all you do is you kubectl apply this file. This is going to be in the examples as well. And with that, you need to wait for it to roll out. This is obviously about the minute that we have sped up, right? After you apply it, it would probably be about a minute before these conditions succeeds. And that part is cut out for the purposes of not having to wait here all the time for it. As I said, the Scylla cluster status has conditions that describe what the operator does and what is the state, right? So there are essentially 3 conditions that you need to wait for, and that tell you the state of what the operator is doing, right? That there is a progressing, degraded, and available condition. If you were to look into that status, you will actually see like a reason and a long message describing why is it so you can better understand what the operator is doing to reach the state that you have defined. Or if something is going wrong, you would see why it is degraded, right? Say you bumped into a Kubernetes quota that the admin set for you, and it can not create another pod, right? It would also create an event as well, but you will actually see it here if you were to look for what is wrong. And those 3 are essentially way. Daniel,
there's a question here on the chat. Can I just ask if you recommend using these APIs over and using these ScyllaDB Helm charts?
ScyllaDB Helm charts are not APIs. So the Helm charts are essentially just templates to create those CRDs, right? Helm charts kind of predate CRDs, and that was the time where the Helm charts were useful. With CRDs, right? Like if you had, I don't know, I have an app, right? I want to create a deployment, a service, a pod disruption budget, generally a lot of resources from some input, right? And template those resources. That's when Helm started. Like nowadays, if you have a CRD, the ScyllaDB Scylla template that we provide is actually like one-to-one mapping to a custom resource definition, right? Like it's no longer useful, but people somehow stick with it because they use it for the other apps. So the Helm charts, they essentially create the CRD, right? You have more flexibility in the CRD, I guess. It's probably even more GitOps way to do it. If you use the Helm chart, I won't blame you, but it is one-to-one mapping these days. It doesn't do like extras.
Okay.
I hope that answers the question.
Yeah.
Cool. So 3 conditions you need to check. Obviously, like you could go and watch the pods as well, but this is a more API-ish approach to doing this race-free, right? So we asked for 1 member, right? Like this is our desired spec, and we said we want 1 member to be created. So if we have waited for the rollout, and now we check status regs ready members, pretty printed with printf. It has one member that we asked for. So let's just have a look at the resources that were actually created. So the user creates the Scylla cluster resource, and the operator on the background currently uses stateful sets. So there's a stateful set per each reg, and we ask for one reg, so there's one stateful set, and we ask for one member in that reg. So there's one pod. You can see like stateful set does the ordinal at the end, so you can see day 0 is the first node for Scylla, and it has a persistent volume claim that references the storage. Let's look at the config maps and secret as well. If you were to enable the automatic TLS feature that is alpha, you would actually see like all the serving certs, all the client certs, all the CA bundles here. But today there's just the Scylla config you've created and an out token that is used by the Scylla manager to connect to the Scylla manager agent sidecar. So we have a Scylla cluster, and we want to get the monitoring stack for it, right? So again, now with 1.9, there's going to be an API for ScyllaDB monitoring. So you will just apply the YAML, which defines the ScyllaDB monitoring, and that's all you have to do. Well, you have to substitute one field in the ScyllaDB monitoring, which is the Scylla cluster name, which I forgot to do here, so I'm going to show you at the end. Again, you are going to wait for the conditions to make sure the monitoring is set up. It actually has to roll out like the Prometheus stack, Grafana, and configure the service monitors. Fortunately, speed up here for us, so we don't have to wait. You can see there is a service created for the Grafana, which you can use to access it. There's also a way to expose it on the expose and ingress for Grafana, so you can access it externally. And with it roll out, let's actually try to connect to Grafana using TLS without ignoring untrusted source or anything like that, and using a basic out, right? So the operator actually creates all those certificates for you. So you just need to find out the serving cert, which is what you are going to trust, and you are going to get a username and password that is also present in a secret. So just briefly looking into it, there's going to be a secret. This is your cluster name -grafana -serving CA, which is how you get the trusted cert, which is the serving cert for the Grafana, and you are going to trust it is going to be your CA bundle essentially. The Grafana user, they are stored for a basic out, again in a secret that starts with the example, which is our Scylla cluster name. And there is a suffix Grafana admin credentials. And in the data, you can find the username and the password as well. So let's try to use curl. You can see there is no -k or anything that would ignore any kind of error, any kind of certificate error or anything. This is like fully TLS setup. Right, like I put every drivers just because the Grafana takes a bit to get configured even after it claims to be ready. But this is just for the purposes of the demo, right? That there was one failed call, but the next one actually got us 200. We use the basic out here, and you can see we use the CA bundle from the serving cert, and none of this ignores certificate errors, so you are secure there. So at the end, I want to show you how you can get a 3-node cluster, right? Like you start it small and you want to grow, right? So essentially, everything you need to do is just to change the spec data center regs, the first reg, and the members field to 3, right? That was the part where we set up one in the YAML definition. You could do like kubectl edit and actually like edit the YAML, but for scripting purposes, here's the patch call, which just tells API server how to patch that YAML file and apply it on the server side. And with that, you just need to wait for it to roll out. This is obviously gonna take a while. Would be a good few minutes, but this is all you have to do. You can see we waited for the conditions, and let's check how many ready members there are. And you can see the status again. Ready members is printed, and now it has 3 members. So that's how easy it is with the operator to get new nodes, essentially. That would have been quite a pain with VMs. Again, here's a look at how the setup looks like. You can see the Scylla cluster we created before. And you can see there is still one stateful set because that's per rack, but now it has 3 pods in it. There is also a Prometheus stateful set that is used by the Prometheus operator. We don't list deployments, but this pod is coming from a Grafana deployment. And you can see the 3 pods for the Scylla clusters that got created and that got configured to join the cluster we have. And you can also see there are 3 persistent volume claims that define the storage for that Scylla cluster. Just taking a look at the config maps, that has grown a bit. That's because we have set up the monitoring that is using the automatic TLS certs. So you can actually find all of those here. Those were the ones that we were getting to get the CA bundle, right? That's the Grafana serving certs. There are also the CA bundles for Grafana to Prometheus connections. If you look at the secrets, there are here are the credentials. Here are the serving certs that are mounted into Grafana. Here is a client CA that is used to secure the Prometheus to Grafana using MTLS, so it's all secured. Yes, Daniel?
We have 5 minutes left only, so.
Yeah, this is like literally thanks for watching. But thanks for the heads up. Yeah.
We have a question here that Felipe answered, but I think that's good to you also answer it. Any plans to add Loki thoughts on his stack for exposing cluster logs through the Grafana?
Loki?
Yeah.
We don't really have anything that we would set up with it. If you can somehow hook it into the Grafana / Prometheus deployment, or just for the logs, right? Like whatever works at Kubernetes is going to work here. That's probably the best one. I get you.
Okay.
Like I know there are some logging scraping platforms for Kube that will just give you the logs for it.
Okay, thanks for the answer.
Okay, just click through the dashboards, but anything else? Is there anything open for the questions, Daniel? I haven't really been following the chat as I was presenting that.
Questions were answered, but if someone have anything else to ask, now it's time. We have 4 minutes left, and it's be good to answer right now.
Yeah, don't be shy.
Yeah. Also, there's your contact links like Slack and so on.
Yeah, actually messed this up. Like this was my last slide, so
Just don't worry about that.
I turned off the screen share too early. Give me a sec. Hopefully I get the right window. Yeah, that was this. It's one slide to show off. If people want to get the contact links.
Jason just put an answer about the Loki question. It could easily be put it in. The biggest thing was how are the logs outputs? Loki works best when the logs are the JSON format.
What I can tell you is we get the logs that are coming from Scylla, right? So there is nothing specific about the operator. Well, that is a bit of prequel that the starter from the operator logs, but I'm not actually sure whether Scylla can log JSON. I don't think it can, but I'm not the person to ask. So if you care about the output, if Scylla can do that, you can do it on Kube as well. But yeah, it's not logging structured by default, that I can tell you.
Well, I think that's it then. So thank you so much for your presentation. And now we're going to head to the stage, I guess.